Hello, Professor Gavimala. I'm Vinay Murthy, and this is Data Mining Assignment 3. I'm going to be using SAS Enterprise Miner to do data analysis. I'm going to shift the screen now. This is the interface for SAS Enterprise Miner. We have to create a project. Under the project, we have to create a diagram. In a diagram, we have to create a flowchart where different steps have to be used in the data analysis. First, I've imported the file. I've used the file import function where I imported the file. I've imported the Titanic dataset. I'll be showing the variables. So my predicting variable will be survived. That is, I'm trying to figure out whether a person survived or no based on different variables like passenger class, fare, boat age, and I've dropped many columns which I thought was not necessary. The next one is the statistical exploration. The I've used this to find out the significance of each column with respect to our predicting variable. As you can see, sex being the most the most significant column makes sense because in reality as well, the women and children were the first to escape from the drowning ship, and afterwards fare again makes sense because higher class people demanded that they need to be saved first. So these are just visualizations I've used for basic analysis. One more thing we can see is the missing values. There are a lot of missing values in a lot of variables. So to deal with that, I've used the impute function. This is the first concept I'm explaining. Impute is used where we replace missing values, and why we do this is because particular it might reduce our training data size where our model needs to train on, needs to learn on, and it might help directly the predicting capabilities of our model. I've used the decision tree and neural networks. Decision tree doesn't concern itself with this because it has its own way of dealing with missing values. That is, it has tree surrogate concept, but neural network and regression, if they find any missing values in any variable, there are good chances that it might drop those variables, which will, as I told, will directly affect the predicting capability. Next, when I was exploring each variable, I found many variables to have skewness. I'm going to be showing now. I'll pause the video for now. Okay, it has loaded. As we can see, fare, parse, and all these values have a lot of skew. All these variables have a lot of skewness in them. So it's better to use logarithmic transformation and to reduce the skewness and get rid of this too much variance in the data set and bring some stability to the data set. And this is the second concept which I've just explained. This we are doing because the skewness will improve, it will just increase biasness in the training in the data set, which would result our data to get overfitted or learn in a particular biased way, and it might do very badly on our training and on our test and validation set. As you can see, the skewness for 433 has reduced to 0.11, showing that there brings about certain stability in the various variants. The third concept I'll be explaining is data partitioning. Data partitioning is, as I previously told, it's a way we split our data set such that we split it in three: training, validation, and set. Training is used where the model is fit into the data, where the model learns from the data to predict from the labels. Validation test is pretty similar. Validation test, they are held out data which is being fed into the model after the training to see how actually the model reacts. These both are used as evaluation to find out the best model there is, and even validation is even used for tuning our parameters more. This is the third point. And decision tree, these are the two models I've used: decision tree and neural network. For decision tree, I've used entropy as the splitting criterion, that is ID3 algorithm, where on what basis the nodes need to be split, and I've adjusted the maximum depth and leaf size as 8 and 6. I've played around with these numbers. To reach this optimal solution. I won't be able to show because of time constraint. Neural networks, again, I've I've chosen the network to be multi-layer perceptron, and number of hidden units is the depth of it. That is the how many hidden layers need to be. That's the depth. So these both work in a very different way. Decision tree works under the assumption that lesser the tree, the better. Neural network works under the assumption more layers, more weights multiplied with these inputs would give a better output. But again, there's a trade-off between the depth in the neural network, because too much depth will result in overfitting of the data of our model. Sorry, and for optimization, I've used backpropagation, which decides the learning rate and the momentum as well. So what backpropagation does is it tunes the weights, as I told before. It tunes the weights uh, of each data such that the predicted value, the error between the predicted and the actual value reduces up to the point that is the optimal solution. It keeps doing that until the model can reach its optimal solution. Um, that is the fourth concept I've explained. And finally, I'm going to do a model comparison. The model comparison, I have chosen misclassification rate, where just a second. So the training misclassification rate. The first one is the tree, and the second one is the neural network. The misclassification rate is 0.19 and 0.16 for both in training. For validation, it's 0.19 and 0.20. Our neural network is slightly high misclassification rate for validation, but the test, as we can see, both are doing almost the same. So we can come to a conclusion that both are almost the same. If we have more, if we need to understand more about evaluation and more how to evaluate these classifiers even more, such that we can come with a conclusion saying this classification is better, this classifier is better than the other one, is using this confusion matrix, which again gives a misclassification rate, but it gives a better picture, like true positive and false negatives. Like with so many people survived, how many did our model correctly predict them to have survived, considering all the variables which were there. And false negatives are for the people who are for the people who need it to be survived, like people who survived our model predicted as not survived, and the ratio between these both gives us the misclassification rate. That's about it for this video. Thank you.